Hey guys and gals, what we did last class or last time, we talked about separating a vector up into its two components. This time what we're going to do is we are going to separate these objects up into two components so we can see if we've got so this rabbit and this horse are carrying this 10 pounds, what we need to figure out is how much each one of them is carrying. So we're going to split it up and we're going to figure out what each force is first, because we know that this is 10 pounds. What we don't know is what this and this is. So we're going to use the law of sines to figure that out. And then after that, we're going to break these up into their components so we can see how much each animal is carrying. So the two of them are carrying a box, and I am going to call this, I should have done that with a ruler because it looks like crap, a box of carrots. Okay? Each animal loves carrots, and they're carrying this box back to their farm so they can eat it. Okay, so this bothers me. I don't know why, because it looks like garbage. So I'm going to draw in my box here, my box of carrots. So my rabbit and my horse are carrying a box of carrots. Obviously the horse is taller than the rabbit, so what we're going to do here is we're going to make this actually as simple as humanly possible. We're going to make, we're going to make this, because this is very, very, very important for us. We're going to make this 60, and we're going to make this 30. So we have a 30, 60, 90 triangle basically for each one of the calculations. One's going to be longer and one's going to be shorter. So what we want is, some people call this tip to tail. We need to turn this into a triangle so we can solve the bit of information. And what I'm going to do is I like to start with the straight one, or the one that only has one component. So we're going to do this, and what I'm going to do is I'm going to make this 10 pounds and equals C. I'm going to make this C. And then I'm going to take my 60-degree angle. So like what I'm doing is I'm making this so all of them turn into a triangle. So this one, this line here comes out at 60 degrees. So I came down to this point. So I'm going to start at that point, and I'm going to come out this way. I like to do it this way, so I've got this line that comes down here. And at this point, there's only one that goes that way. I could draw my triangle this way, but I'm using horse. So I'm going to go out this way, 60 degrees. So this is, I should do it this way so you guys can see. So this is 60, right? 60 degrees, which makes this 30 degrees. Okay? And then this coming this way, come on buddy, coming this way is 30. Okay? And then I've got this coming down here, so this goes up this way, and then this. So this going off this way is H, vector H, and this is vector R. Okay? And then so if this is 30, okay, I need to make this 30, which makes this 60, and easily this is 30, and we need this to be 180 degrees, right? So every triangle is 180 degrees. So I've got 30, 60 plus 60 is 120, which leaves this as 60. So this is 90, where this, it doesn't look like 90, it should be 90. I didn't draw it very well, but 90 plus 30, which is 120, plus 60 is 180. All right, so then this is actually 90 degrees. Okay, so it's actually a 30, 60, 90 triangle again, which is a 30, 60, 90. I tried to make it as easy as possible. But, so what we're going to do now is we're going to solve this, because I need to find out R. This here is the exact same problem that we did here with the law of sines. So we need to find out what vector R is and vector H. Okay, so all we're going to end up doing in the end is adding one more step. So I have, I'm not going to write the law of sines because I need this space to draw and write. But I have, I'm going to start with, I know sine 90 over, so sine 90 over 10, so 10, okay, equals, and I'm going to do 30 over R, so sine 30 over R equals 10 sine 30 divided by sine 90 equals R, I meant to do this, vector R, which equals, so let me get my graphing calculator, and we'll do sine, wait, here it is, 10 sine 30, and if you remember, sine 90 is 1, so 10 sine 30 is 5. 5 LBS. I can feel the physics people rolling in their graves. This is just the way I like to do it. I know it's wrong, but whatever. I don't care. So then the next thing I have is sine 90 over 10 equals sine 60 over, so 60 over H, vector H, or horse, equals 10 sine 60 over sine 90. Remember, sine 90 is equal to 1, equals vector H, which equals, let's do this again, 10 sine 60, and remember, divided by 90, so 8.6603. Okay, that's good enough for me. Okay, so that is how much they are carrying. Now, if you look at this, so we add these up, right? Plus 5. They should equal, if that's what they're carrying, they're both carrying 13.66 together. So together they are pulling more than 10 pounds of carrots. So while they're carrying this, they are actually carrying more, whoops, that should be right here. They're actually carrying more weight, or pulling the amount of force that is greater than 10. Here is the question. Why is that number? Why are they pulling more than the weight of the carrots? That is the important question. And I'm going to tell you why. And hopefully you'll understand. They are carrying this 10 pounds, definitely, because both of them together are pulling more than the actual weight of the carrots. The reason they're doing that is these lines or these chains or whatever they're using to carry it with, they are pulling against each other. This is a free body diagram. This is exactly what a free body diagram tells us. What we're going to find out is that each animal, the rabbit and the horse, are both together carrying this 10 pounds. They are also pulling in these directions. So what I'm going to do is I'm going to make the actual free body diagram, and it's actually going to be very different. We are going to be doing something. We have a point that is right here. This is that vertex, or that point. Those animals are pulling this direction and this direction. Now, this is the most important part of statics. Okay? The most important part. We have, I'm going to draw it this way so you guys can see. This is rabbit. This is, I'm going to actually make it bigger on purpose. This is horse. This is rabbit. Y. Actually, you know what I'm going to do? I'm not going to write the whole thing because I need that space. Oops. So these are the Y components. So this is HY. This is RY. I don't need my ruler down there anyway. This is going in this direction. This is HX. And this is RX. These numbers should be exactly the same. Equals, and I don't know what that number is yet. RY plus HY is going to equal some people like to call it the force. I'm going to call it CY equals 10 pounds. Nobody carries 10 newtons of carrots. They carry 10 pounds of carrots. That's why I'm using pounds. Okay. I forgot to put it up here. LBS. Okay. So this is now my first free body diagram. And I'm just going to do this for you to make it a little bit easier. I'm going to go like this. And I'm going to create this, and I'm going to call this H, vector H. Then this direction is going to be at a 30-degree angle-ish. 30-degree angle. This is R, vector R. Okay? That is my first free body diagram. Okay? So let's solve for HX and HY, RY, and XRX. Okay? So I'm going to do this a little bit smaller because I need this space here. So I'm going to say, I'm going to take, let's see here. I'm going to go like this. I'm going to do R first. So I have, and like this. I've got R equals 5. This is 30, 60, and 90. I don't need to do the 90. And then this is Ry. Rx. Excuse me. Rx. Ry. So I have now, I'm going to do 5, right? Sine 90 over 5 equals, excuse me, sine 60 over Rx. And I'm going to do these also. Sine 90 over 5 equals sine 60, 30, sine 30 over Ry. Okay, so we'll say Rx equals Ry equals, and then we'll do our math here. So clear. I didn't do this step here, but I'm just going to do it. So 5 sine 60, 5 sine 60 is 4.3301. And then sine, clear, and then 5 sine 30 is 2.5. So here is what's important, and this is what I want you to understand. So this, Ry is 2.5, Rx is 4.3301. Technically, you don't have to do any other math. I know that Hx equals the same as this. So this is going to equal 4.3301. This, Hy, 10 minus 2.5 is 7.5 pounds, whatever. So this horse is carrying 7.5 pounds of the carrots. The rabbit is carrying 2.5 pounds of the carrots. And then they were pulling 4 pounds against each other, which is pretty crazy. That's a lot of weight to be pulling from each other. So in the long run, it probably would be even better for just the horse to carry the carrots instead of working with the two of them, because in the end, he is almost carrying all of the carrots anyway with all of the force that he's carrying. So anyway, that is our example of our first free body diagram. And this is the most important part. I'm going to do this. This is I don't know why I said that. This is the most important thing about statics. Everything equals 0. Zero. Everything equals 0. I know I did a theta symbol, but whatever. Everything equals 0. That is pulling this direction at 4.3301. This is pulling in that direction, 4.3301. And this is pulling in 10 in this way, and this is pulling 10 in that way. So everything at this point is now equal to 0, because everything is pulling in an equal fashion. And the last thing I'm going to do here real quick is I'm going to use that number, and I'm going to say 8.66003 sine 60, which is 7.5. 7.5. I know, don't worry about all that other crap. That's because I rounded it off. And then 8.6603 times, or sine 30. 4.3302, 4.3301. That's close enough because I rounded that number off. That's it, okay? That's all I have. I know that was a long video.